Hello students, so today we are continuing the power energy analysis of electrical circuits. So in the last class we have seen the power delivered by a battery when it is discharging and power absorbed by the battery when it is charged, resistance and other passive devices. Okay, just we have studied about resistance only. They will absorb power. So battery will deliver power, resistors will absorb power. Okay, and we have done some problems also. So today we will be seeing power rating of an appliance. So power rating of an appliance in a simple term, in order to understand, if you are going to an electrical shop and if you want to buy some bulb, you will be saying like I need a 100-watt bulb, or I need a 50-watt bulb, 60-watt bulb we used to say. So what is this 50-watt bulb I need? When I say that is also a power. So we have studied about power dissipation. Okay, power dissipation we have studied. Suppose if a current I passes through a resistance, if there is V voltage drop, then power dissipation we say I square R or V square by R. This is power dissipation. 25-watt bulb or 60-watt bulb, okay, and along with that they say 220 volt. Okay, 220 volt. What is its meaning? So this is we are going to discuss about power rating. Okay, so power rating is nothing but the power which can be dissipated, okay, if we connect that device or appliance along a 220 volt supply. And 220 volt supply is what we are getting at home, that is AC. We are discussing here is DC, but RMS value of AC is what is 220 volt. We will be studying that in detail in alternating current, another chapter. So here the meaning is, the simple meaning is, with an input of 220 volt, with an input of 220 volt, 25 watt of power will be dissipated. What about this bulb? This is one bulb B1, this is another bulb B2. So with an input of 220 volt, 25 watt power will be dissipated. With an input of 220 volt, 60 watt power will be dissipated. This is what is its meaning. So from this input, what we are taking is, one thing which we are taking is, we will be able to find resistance. Okay, how we will be able to find resistance? Voltage will be given, say for example in this case 220 volt, and power also will be given, say for example 50 watt, and power is equal to V square by R. Okay, so for this input voltage, this much power will be dissipated, and resistance of a device will not change, that will be constant also. So R is equal to V square by P. So just by substituting 220 square by 50, we will be able to find resistance. Once if we find resistance, then that is no more a bulb for us. We will be just seeing that as resistance, and we will solve the circuit easily. We will be able to find how much energy will be absorbed there, how much power will be dissipated there, how much will be the brightness. All these things we will be able to measure once if you understand resistance. So when someone gives this data, power rating, for someone who solves a problem, or a person who is attending Neet or JEE, okay, an exam point of view, what we are getting from power rating, from the input of power rating we will be able to grab the value of resistance. So once if we get resistance, we will be able to solve the problem easily. Another thing we will be able to get from this is nothing but maximum current, maximum current. So we get resistance, okay. So based on series connection or parallel connection, if you have resistance, voltage, power, everything, we will be able to find maximum current. What is maximum current? Maximum current the device can handle, okay. Beyond that, if we send some current, the wire may melt. You might be knowing about the fuse wire at our home, okay. We have a fuse wire. If a heavy current comes in, okay, the fuse wire will not be able to bear that much current, it will be melted. So that is a safety measure for the entire house. So it will be melted, current will be disconnected, and house will be safe. So same current, if it is allowed to pass to our home, okay, many appliances, many devices will get damaged. So the maximum current a device with which a device can handle, all these things we can get from here. But most of the questions, okay, most of the questions discussion will be based on this. This is also an additional information we will be getting from power rating. When we say 100 watts is the power, okay, 100 watts bulb, if we say 100 watts bulb, if we say, it means that 100 joules of energy, okay, 100 joules of energy will be consumed per second. This is the meaning if we say 100 watt bulb means, okay. So, and brightness of a bulb, okay, how much brighter the bulb will be, okay, this is proportional to power consumed, okay. Brightness of a bulb is proportional to power consumed. If more power is consumed by the bulb, means that it will glow brighter, okay. Less power consumption, less brightness. More power consumption, more brightness, because the energy which is going to dissipate will be coming out as heat energy or light energy. So that will glow, okay, that will give a glowy appearance, so that we are converting into our usage, our based on our requirement we will be converting into that. So brightness of a bulb is proportional to power consumed. Take this question. Question says an electric bulb is marked 100 watt 220 volt. An electric bulb is marked 100 watt 220 volt, okay. So an electric bulb, okay, this is marked 100 watt 220 volt, okay. So if the supply voltage drops to, if this is drops to 110 volt, then what is the power dissipated in the bulb, okay. So this is the 100 watt is the power dissipated with the 220 volt supply. That is what the power rating which is given. Now instead of having this much, they have given 110 watt, it is reduced. Now what is the new power? That's it. So from this, what we will be able to do? We will be able to find resistance, as I said before. So P is equal to V square by R. R is equal to V square by P. V square is 220 square. Divide by P is how much? 100. 10 will be cancelled off. 22 is nothing but 484. Now if we need to find this power, this is nothing but V square by R, 110 into 110 V square divided by 484. So just solve this. 11 into 11 is or otherwise we can cancel here itself. For 44 this will become 4 is there again, 44. So here if we cancel, this will become 4. So what is there? 100 divided by 4. So this is nothing but 25 watt. Answer is D. Okay, note it down. Take this question, students. Two electric bulbs rated at a 25 watt, 220 volt, then 100 watts, 220 volt are connected in series across a 220 volt source. If 25 watt and 100 watt bulbs draw powers P1 and P2 respectively, then what is P1 and P2? So the question is nothing but its power rating is given and it is connected in series. So how much power it will draw? That is the question. So this question they have asked in 2019 mains, 2019 JEE mains. This question they have asked. Okay, so what we need to do? Power rating is given. Bulb B1 25 watt, 220 volt. Bulb B2 100 watt, 220 volt. So they are connected in series and respective powers will be drawn. That's it. So what we need to do? We just need to find resistance R1. So R1 is nothing but P is equal to V square by R. So R is equal to V square by P. So resistance R is equal to V square by P. So V square is 220 into 220 divided by 25. So this is what is R1. Okay. Now R2 is 220 into 220 divided by 100. So this is going to be, this zeros will be cancelled off. This is going to be 484. What about this? How much is this? Okay, it's 4 times will be this, because it is divided by 100. This is divided by 25. So this is going to be 4 into 484. Okay, so we got R1 and R2. Okay, can you please note it down? I need to erase this. Alright, done. Okay, so we'll remove this. P1 and P2 is what they are asking. Okay, so R1, R2, it is there. Now they are connected in series. Okay, now this is bulb 1. Okay, now B1 we got its resistance and B2 also we got its resistance. This is B1 and again this is B2. This is again another bulb. Okay, bulb, and we are connecting that to a voltage source in series. Now B1 is 4 into 484. Its resistance is 484 ohm. Okay, let this be 220 volt. Now how much will be the power dissipated in B1 and B2? This is what they are asking. So we need to find current. Okay, we need to find the current that is passing through the circuit. Okay, current will be same. Current will be same in both the resistances. So P1 is equal to I square R1 and P2 is going to be I square R2. So how to find I? I is V by R equivalent. So what is R equivalent? R equivalent is R1 plus R2, that is 4 into 484 plus 484. So we can say 5 into 484 is the current resistance. So V is 220 and this is going to be 5 into 484. So this is the current which we have got in the circuit. Okay, so solving this we will be getting this as 1 by 11 ampere. Okay, 1 by 11 ampere current we will be getting. So using that current we will be able to find P1 and P2. So P1 is equal to I square R1 1 by 11 into 1 by 11 into R1 is 4 into 4 84. So I square into R1. So if you simplify this, we will be getting 16 watt, and this is P1. P2 is equal to 1 by 11 into 1 by 11 I square into R2 is 484. So this is just by doing this 4 times it will be there, then again 44 will come, that also will be 44. So again if we multiply, this will be 4 times. So that is how 4 watt, 16 watt and 4 watt. Option A will be the answer. Okay, so the question was simply two bulbs with their power rating is given. So from that we found the resistances, and those bulbs are said to be connected in series. So that resistance we will connect in series. We will be finding just the power dissipation through those resistances, which is nothing but bulbs. Okay, so power rating is given just for giving us a clue on the resistance of the bulb. So once if we find the resistance, for us it is simple resistance so far whatever we have learned. Okay, they are not just bulbs for us. For us it is going to be just resistances. Connect in the circuit and find the current if it is series. If it is a parallel connection, we will be able to use voltage, because voltage across all the bulbs will be same if it is connected in parallel. Okay, take the next question. The power rating of 3 bulbs A, B and C are 25 watt to 220 volt. So this is of A, 25 watt 220 volt. With the 220 volt supply, 25 watt will be dissipated. 50 watt 220 volt, 100 watt 220 volt. 3 bulbs specifications, power rating. If these 3 bulbs are connected in series to a DC supply, which bulb will glow brightest? Okay, so if they are connected in series, which bulb will have more glow, which will be the brightest? That is the question. So how we will solve? So bulb A, bulb B, bulb C. Since same current is going to flow through this, suppose once if we find current, okay, I, same current will be flowing through the circuit. So power is going to be I square R. So from this we can say power is proportional to resistance. Power is proportional to resistance of each bulb. So what is the resistance of A? Resistance of A will be V square by P. So 220 square divided by P is nothing but 25. In this case RB is nothing but again 220 square divided by 50, and in this case RC is 220 square divided by 100. So which is having more resistance? So here this numerator is less here, moderate here, denominator is more in this case. So we can say RA is greater than RB is greater than RC. So because of that, which one will glow brightest? Bulb A. So okay, bulb A is having more resistance, so bulb A will be glowing with the more brightness. Clear? Next question, students. So here this question is same. A, B, C bulb 25, 50, 100 all are 220 volts. If these bulbs are connected in parallel to a DC supply, which bulb will glow brightest? That is the question here. So we can say if this is 220 volt in parallel connection, In series connection, current will be same through the circuit. So in order to find power, it is easy to concentrate on current. P is equal to I square R. If they are connected in parallel, V square by R is the easiest method, because voltage will be common. It is same for all. So if this is 220 volt, here also this is going to be 220 volt, plus minus, everywhere it is going to be 220 volt. So if we need to find power is equal to V square by R. So in this case, power is inversely proportional to what? Resistance. Okay, so when we try to find resistance of A, B, C, V square by P. So 220 square divided by 25, 225 square divided by 50, 220 square divided by 100. So obviously RA is more than RB is more than RC. RA greater than RB greater than RC. So power and resistance inversely proportional. So power will be more for C. PC, PB and PA. So which one will be glowing brightest? C will be glowing brightest. So this is the difference in the case of series connection and parallel connection. Please note it down. So okay students, so one part of current electricity is this power and energy analysis. In that simply power dissipation we will have to find. Another category of questions is like how to find power dissipation, and power rating will be given, especially bulb or any kind of appliances can be given in the question. For us they are all simply resistances. Okay, so try to find some more questions and try to practice. Goodbye students, good luck, study well.